Hi everyone, welcome to my channel. Today we'll talk about how to conduct a systematic field measurement. And if you like this video, please don't forget to like and subscribe. Thank you. Here's today's presentation about microclimate measurement in subtropical cities, systematic review, and the proposed guidelines. 2 months ago, I published a guideline paper collaborating with several professionals, so today's presentation will be based on this paper. As we already know, field measurement is very important, but field measurement contains many details that would influence the accuracy of measurement result, and our landscape student may not have enough experience in how to select the instrument, how to select a field site, how to respond to unexpected conditions. So therefore, we need a guideline to tell us how to conduct a proper microclimate field measurement. And despite existing guidelines and standards about meteorological observation, such as the WMO guidelines and the ISO standards, when it comes to the microclimate field measurement in a complex urban environment, I think there are three issues. First is about the application scale. Currently, the previous meteorological observation guidelines are focused on the standard climate stations. So they focus on the local scale but avoid the microclimate effect. And some standards are initially developed for indoor or working thermal environment, such as the ISO 7726 standard and the ASHRAE handbook. And for the application location, as we know, the urban microclimate is a complex system, strongly affected by high-rise buildings, the narrow street canyons, changeable anthropogenic heat and cooling, and complex human activities, etc. So therefore, we need a guideline includes the considerations of the complex urban environment. And another point is about the systematic workflow. So from the literature review, we find that some existing guidance mainly focus on the equipment instructions, but few mention the experimental workflow, including the pre- and post-processing. So therefore, it is essential to provide the researchers a clear path to consider every detail in urban microclimate field measurement. This slide shows the approach to formulate the guidelines. We did a comprehensive and systematic literature review, and we focused on the last 5 years field measurement studies. We try to summarize their experience, and we also want to see is there anything can be done better. And we also review the existing standards and the guidelines. We want to extract the useful concept and method into our field measurement guidelines. So from the literature review, I found that many things can be done better in future microclimate field measurement. So my colleagues and I proposed a field measurement workflow and guidelines. And we suggest a 4-steps workflow, that is formulating field measurement plan, preparing for field measurement, sustaining measurement quality on the test, and creating data. For each steps, we list all the detailed hints, precautions, and recommendations that we thought are important and cannot be omitted. The first section of this guideline is formulating field measurement plan. The first step is to establish clear measurement objectives. As we already know, a clear understanding of the research objective can facilitate the plan's realization. And from the literature review, we find that there are two common used research objectives. One is to evaluate the outdoor thermal environment and its driving factors, and the other is to assess the outdoor human thermal comfort condition and the thermal perception from both subjective and objective perspectives. And we also find sometimes both research purpose may appear in the same study. And the next step is to determine field measurement type. Refers to T.R. Oak's book Urban Climate. There are three kinds of field measurement. One is fixed and mobile, and the flow following approach. And the choice is depend on the research aim. And I can tell you the fixed one is the most common used method, but it has high demand for instrument and manpower. So some researchers will also use the mobile measurement. They usually use a so-called stop and go strategy, which is a variant of the mobile approach. And it includes stops at a specific transect point to take measurement. And for the flow following approach, this is also a special form of mobile measurement. Usually use the blooms, bubbles, and the colored gas or smoke. But I have to say, the flow following approach is not commonly used in the microclimate field measurement. So in my guideline, I will not discuss this research approach. And the next step is to select and characterize the field study site. One of the important things we need to focus on is the site representativeness. The result of the field observation can represent the range of urban areas. We call it site representativeness. So for example, in Bangkok, Hong Kong, as we can see in this photo, its site dimensions can represent the surrounding neighborhood in a large scale because of the homogeneous urban form. So therefore, there's no need to set many measurement sites in this case, because when you set your site here, here, or there, the results are almost the same. And in contrast, a site in a hilly or coastal location such as the Causeway Bay in Hong Kong, so only one or two measurement sites are unlikely to represent this zone's climate. So instead, a network of measurement sites is required to assess the spatial microclimate characteristics. And when we select the measurement site, the control variable method is the most common way to investigate the thermal effect of urban element. So usually, researchers would like to use the LCD classifications to help them select a specific urban form. And for some specific studies, additional criteria need to be considered. So for example, if your study also contains questionnaire survey, and I suggest you considering the visible and accessible to most participants. And if your study is focused on trees, I will suggest you avoiding surrounding thermal influence on your sample tree. And there's another two important points in site selection. One is don't forget to consider the availability of permitted space and electrical power. And the other thing is about the field trip. Field trip is impossible because it is impossible to fully understand the site condition in detail from digital maps or from satellite images. So for example, this is the K11 Museum. It is a shopping mall, but in Google Maps, this place is under construction. But actually, this shopping mall has been built. So if you don't take a don't take a field trip, you will miss this perfect measurement site because it has beautiful green roofs and vertical greenings. And the other important point is the field site documentation and the metadata. I have to say in a paper, if we only describe the field site by their names, that is not enough. So for example, if I tell you I did some tests in Bangkok, in Sunny Bay, in Shantripur, and Jiangguanao, I think these names of places means nothing to you because you're not familiar with Hong Kong, right? So for this point, our guideline paper provides a metadata checklist. According to the WMO guideline, all the information or data about the measurement data, we call it metadata. And for this checklist, we refer to the WMO metadata standard and the reviewed studies. Sorry. And we also apply the Hong Kong, and we list all the items that we think that's important and provides the definition. And we also apply Hong Kong as an example to show the metadata for local environment. So if you want to describe your city in your paper, I will recommend this checklist for your reference. And moreover, it would be good to provide more quantitative information about the urban climate, such as the annual or monthly mean or maximum or minimum air temperature and the relative humidity, as well as the wind rows. And in my guideline paper, I also used the data from Hong Kong Observatory to provide an example for readers. Sorry. And if you want to describe the site characteristics, there are two kinds of information that necessary to describe your measurement site. One is the site map and photos, and the other are quantitative and quantitative descriptions. About the site map and the photos, we provide an example for you in the guideline paper. And the OAK suggests using an aerial photograph as the local scale map. It is recommended because it furnishes details of buildings and trees. And for the site photos, including the panoramic photos, it can provide a perspective view, supplementing the details at the pedestrian level. And if you want to give a view of the sky occlusion conditions, I will suggest you using the fisheye lens photos. And for the qualitative descriptions, I suggest you refer to our metadata checklist. And for the quantitative descriptions, I would like to suggest you using the urban morphology parameters. Because it can be objectively compared and analyzed in assessing the thermal effect in different sites. And in my guideline paper, in its Appendix B, I summarized the frequently used urban morphology parameters in microclimate field observation studies. And there are several categories about the sky occlusion conditions, street canyon, building, and greenery, and water body like this. And I list all the parameters here and their definition and calculation method. And I believe it will be a very helpful and useful material in your study. And when you calculate the urban morphology parameter, you need to set a buffer size first. And from the literature review, I found that 10 meters, 20 meters, 150 meters, 250 meters, 300 meters, and 500, 700 meters are all used in previous studies. So for your study, I think a sensitivity test should be conducted because the suitable buffer size varies from research areas and the selected parameters. And after introducing the field site, so now let's talk about the microclimate variables and the instrument. So in general, the air temperature, relative humidity, wind speed and direction, radiation, and surface temperature are common used variables in the microclimate field measurement. And the TRO mentioned in his guideline that the sensors used in general meteorological stations are appropriate in urban areas, including their accuracy and response characteristics. But when you put your thermometer in an outdoor environment, the temperature and the humidity sensors may be heated by the radiation sources such as the sun and the surrounding warm urban surface. And under an extremely unfavorable condition, the air temperature could be overestimated by up to 25 K. So therefore, a radiation shield with proper ventilation should be applied to minimize the radiative exchange between the instrument and its surroundings. So here I list some points can be considered in selecting the thermometer and the radiation shield for your reference in my paper. And if you want to select the instrument to measure the wind speed and the direction, here, as you can see the photos in this slide, there are various anemometers based on different techniques, and their selection mainly depend on wind characteristics in the urban study areas. And in my opinion, I would like to recommend the omnidirectional or three-dimensional anemometer because it can capture the turbulent flow in urban areas. But I have to say this kind of anemometer would be expensive. And if you want to choose the less expensive anemometers like these ones, please remember that these are unidirectional or bidirectional anemometer, and it can be applied for the unidirectional flow situations such as the straight canyon. And for the radiation-related variables, most researchers would like to use TMRT, that is mean radiant temperature, to investigate the radiative exchange between the human body and the surrounding environment. And the various methods for estimating TMRT has been reported in ISO 7726 standard, and I suggest you to have a look at it. And generally speaking, the six-directional method is the most accurate method, but however, it needs 3 pairs of hydrometer and a pyranometer. So that means this method is expensive. But if the budget allows, I would like to recommend this method. And alternatively, you can use global temperature to estimate TMRT. A medium gray globe with a 38 to 40 millimeter diameter is recommended. You can see this photo. And in terms of the surface temperature measurement, there are 2 ways: the contact and the non-contact measurement are the main 2 approaches. I have summarized their advantages and their limitations in this table, and you can find it in my guideline paper. And in my opinion, I would like to recommend the thermocouple because it is accurate and less expensive. But I have to say it needs a data logger to save the data. And in general, a data logger needs electrical power and batteries. So you need to consider this point. And for the thermal image camera and the temp gun, I believe you are familiar with it due to the wide use during the COVID-19 pandemic. It is easy to use, but if you want to get an accurate result, you need to know the long wave emissivity of the object. So, okay, once the measuring variables and their corresponding instrument are determined, the instrument metadata should be documented in detail. So here is the metadata checklist of instrument for your reference. And then the next step is don't forget to set a reference station in the nearby open areas. As you can see in this photo, this is the field site and the reference site in my previous experiment. So by comparing the difference from the tree shading area and the nearby open area, we will know the thermal effect of this mango tree. And then the next step is to choose the field day weather. From the literature review, I found that most researchers will choose the sunny days or clear sky days because it can help avoid the effect from cloud cover and participation. And in some cities such as Hong Kong, Guangzhou, and Taipei, some cities in subtropical climate zone, the cloudy days are more usual than the clear sky days in summer. So the researchers there will choose the partly cloudy days. And in my opinion, since your questionnaire survey and your microclimate measurement may be conducted at different urban sites and repeated several times, so a common weather type should be chosen to minimize the variations among observation days. And Some researchers will also choose the typical summer days or so-called representative days. So for this method, I think a threshold criterion should be applied based on the local weather data. So for example, Professor James selected the typical summer sunny day in Hong Kong as a day with 300 watt per square meters of average daytime solar radiation and no or little rainfall. And for the field date and the time, uh, from the literature review, we find that the researchers will choose the extreme conditions, i.e. the hottest part of the day that is around 3 p.m. and the strongest incoming solar radiation of the day that is 12 to 13 o'clock. And for some studies focused on the human thermal comfort, the research objectives outdoor activity time should be considered. So for this, I would like to recommend this paper from my previous research team. The researcher conducted a survey about the main activity time in each season, and it shows that the residents tend to start outdoor activities from about 3 p.m. in summer. Okay, in this section, I talk about formulating field measurement plan, and I introduce how to establish your measurement objectives, how to determine your field measurement type, and I also talk about the field site, the microclimate variables and instrument, and also talk about how to choose the field day weather, date, and time. The second section is about preparing for field measurement. I have to say, instrument calibration is very important, but always omitted by most researchers. There are two ways for the calibration. One is under controlled conditions, i.e. you can use the climate chamber or liquid bath, and the other method is the field test in actual environment. As you can see in this photo, this is my instrument calibration last summer in Hong Kong. And I will not talk much about the calibration because you can find the specific detailed calibration procedures in the WMO number 8 guidelines. And another important point is maintain your instrument. Keep your instrument clean is very important because the dust and the particle in the air may reduce the sensor sensitivity and measurement accuracy. So for example, if there's some dust on the glass dome of a pyranometer, it will affect the measured solar radiation. And the dust and the particle in the air will also damage the moving part of mechanical anemometers. It will damage their cap or their vane, so you need to be careful. And the other point is you need to store your instrument in shaded and dry locations and check them regularly. So the next step is to develop a weather monitoring system. There are mainly two approaches. One is using the commercial all-in-one weather station. For example, this is the Watchdog weather station. But I have to say it may not meet your requirement. So you need to use a self-developed weather monitoring system. And regardless the type of weather station, we usually mount the instrument at the height of 1.1 meters to 2 meters because we want to focus on the microclimate at the pedestrian level. And for some human meteorologist related studies, a height of 0.6 meter is applied to represent a sitting person. And for the mobile measurement monitoring system, there are various various categories, as you can see in this illustration. And this is a self-developed mobile measurement system from Professor Brown's research team, and this is a backpack monitoring system, and this is a vehicle monitoring system from my current research team. We put the instrument on the top of a car because my colleagues want to focus on the air quality in urban environment. And for the details, you can find in this paper. And there are 3 points I want to tell you. First is that using a bicycle or walking is more flexible because they can overcome the limitation of the road network, the vehicle access, and the ideally urban environment. The other point is please remember to keep enough distance between the operator and sensors to avoid obstructing solar and terrestrial radiation and wind. And I also suggest you using a GPS because it can help you record the location and the time. Then next, there are also 2 important points is the recruiting and training student helpers. It will take some time. And the seeking permission for site access and use is quite important. I can tell you a story about my colleagues. That is quite a sad story because this summer my colleagues plan to conduct a field test in public estate in Hong Kong, and she need to get the permission from the Hong Kong Building Department, and but she how can I say? But it took her more than 1 month to wait for the response from the government. So, and finally, she got the permission in the end of July. But at that time, half of the summer has passed. So that's quite a sad story. So I want to tell you, if you want to conduct a field measurement in public spaces, and if you need to ask for permission from the government, I suggest you contacting them as early as possible. And before the field test, we need to check the weather forecast and prepare some accessories. Here I list some accessories that I think are helpful and useful based on my own experience, and you can also find the information in my paper. And please remember to set your instrument. We need to synchronize the clocks to set the unit and check the power remain in the instrument. And the preliminary test is important because it can be regarded as a rehearsal for the live measurement. Okay, so in this section, I talk about the preparing for field measurement. I introduced the instrument calibration, how to maintain the instrument, how to develop a weather monitoring system, and how to organize a field measurement. And in the third section, I want to talk about sustaining measurement quality on the test. One of the important things is checking equipment and data storage regularly. After starting the measurement, all equipment should be checked at least every 2 hours. And if there is no built-in automatic data saving in your instrument, the saved data should be checked hourly or more frequently. And the other important thing is about the observation log. I think it is important, but a few studies mention this. And through the log, details of field conditions can be recorded. So in my paper, I listed several essential points that should be included in the log, and you can find it in the paper. And then now let's talk about how to respond to unexpected conditions. About the natural influence, I think the unexpected precipitation is one of the most terrible things during the measurement. You can check the IP code, that is the International Protection Marking. This code can tell you how waterproof your instrument is. And in the field test, if the rain is about to fall, please remember to press the save buttons immediately, and your monitoring system should be moved to the nearest rain shelter or at least covered by our waterproof clothes. And whether the field measurement data can be used in your data analysis, that is depend on the research aim. And the other unexpected condition in field measurement is a human disturbance. I have to say the pedestrians, they are quite curious about our instrument. But if they stand too close to our instrument, they may block the incoming radiation and wind and cause a measurement uncertainty. So we need to keep them away from our instrument, and usually I think 0.5 meters is quite enough. And at least one student helper should stay at the site and ensure the safety of your instrument. And after comparing field measurement, please don't forget to collect the local meteorological data of the field day in time. So for example, the Hong Kong Observatory website shows the time series of weather information in the last 24 hours. So you can download it in time, and it can be very useful in the future data analysis. Okay, so in this section, we talk about the sustaining measurement, quality on the test. And I introduce you some important point that I think it will be very useful in your measurement. And the last section in the guideline is the curating data. About the data processing, I would like to provide two examples. One is about the TMRT estimation. So when you calculate the TMRT, please remember that the unit of diameter of the globe is in meters, not millimeters. So I found some researchers made this mistake, but they didn't realize it at all because the correct and the wrong result look similar. And there has been some a recalibration method that you can use in your TMRT estimation, and I would like to recommend this paper from my research team because it has summarized all the existing recalibration method, and you can see this is a useful reference for your study. And many researchers would like to use the thermal comfort index to assess the environment, and the PET, SET, UTCI, and the comfort model are the most common used ones. And in my opinion, I would like to recommend the comfort model. It is because comfort can describe the heat flows of energy to and from a person in detail, including each component such as the convection, evaporation, absorbed radiation, etc. And when you draft your field measurement paper, please don't forget to elaborate the reason for choosing your index. And I would like to highly recommend this paper because it summarizes detail on the essential characteristics or the indices. So, okay, here is all the information I would like to present today, and I hope you will find this guideline helpful to your field test, and I really hope that you can read the guideline paper after today's seminar.